We have two videos on Chapter 4, Section 6. This is the first one on matrix identities and inverses. Does anybody remember what an identity is? Look in here. Does anybody remember what an identity is? Take a second to pause, you can think about it. The identity, I call it's the thing that doesn't change anything. The identity, for example, if the addition, the additive identity is 0, because 3 plus 0 is 3, 0 doesn't change anything. The multiplicative identity, which you couldn't really see, the multiplicative identity is 1, because 3 times 1 is 3, anything times 1 is itself. The functional identity we haven't actually really learned yet, but if you have the function f of x equals x, that function doesn't change anything. F of 3 is 3 and f of 12 is 12. The matrix identity, that's what we're talking about today, the matrix identity is a bunch of 1s and 0s and nothing else. Here's an example of a matrix identity. This I is for identity, and it's got 1s along a diagonal and 0s every place else. And a 3 by 3 matrix identity. You can have matrix identities that are 2 by 2s or 4 by 4s, or any square matrix can be an identity matrix that has 1s along that diagonal. So for example, if I were to multiply these two 2 by 2 matrices, I got the right color here. Well, this would go row, column. So I would do 2 times 1 is 2, 5 times 0 is 0, and 2 plus 0 is 2. Then I'd go row, column, 2 times 0 is 0, 5 plus 1 is 5, I got 2, 5. Then I'd go row, column, this would be 1 times 1, which is 1, and negative 8 times 0, which is 0, so that's just 1. Then it goes row, column, so 1 to 0 is 0, negative 8 to 1 is negative 8. I know all those lines can get a little bit confusing and distracting, but if you kind of take a second and look through this multiplication, you'll note that this matrix times an identity matrix gave us what we started with. 2, 5, 1, negative 8, 2, 5, 1, negative 8. That's with the identity on the right side. The same thing happens with the identity on the left side. So right now I have an identity matrix over here. Here's my identity matrix on the left side. If I go row, column, I won't hide that, it'd be 1 times 1 is 1, everything else becomes zeros. That's just going to be a 1. Then I go row, column, that's just going to be a 2, because these all would become zeros as they multiply by these zeros. This matrix is just going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It's called the identity matrix because nothing changes. Okay, let's talk about inverses. And you remember what an inverse is? And again, you can pause and think if you can come up with a good definition for an inverse. What I always say is the additive inverse is how we get to the identity. The additive inverse undoes whatever's been done. For example, the additive inverse is what we call the opposite. 3 plus negative 3 is 0, so negative 3 is the additive inverse of 3. The multiplicative inverse is called the reciprocal. 3 times a third is 1, since 1 is the multiplicative identity. So 3 times a third is 1, 3 and 1/3 are reciprocals. These are examples of inverses, but not the only types of inverses. There's also a functional inverse. That's something we'll learn about later. Today we'll talk about the matrix inverse, and the matrix inverse is a little bit complicated. Not crazy complicated, but a little bit. Here I have a matrix A. Okay, matrix A is going to be a 2 by 2, and it's A, B, C, D. Well, if matrix A is A, B, C, D, I want to find A inverse. To find A inverse, I have to follow these steps. First I do 1 divided by the determinant of A. Remember, that's the determinant, which we've calculated before. Then I multiply this number, this is just going to be some number. I take that number and do it by this matrix, D negative B negative C A. So I'll go through an example to explain how this works. Here's my matrix A, where it's like I have letter A, B, C, and D. Well, to find A inverse, I would do 1 over the determinant of matrix A. And the determinant of matrix A would be 4 minus 6. So it's really 1 over negative 2. But then I take these numbers right in here, and their order switches based on this little formula down here. So D and A switch spots. So this becomes 4 and 1. And C and B switch their signs. So this becomes a negative 2 and a negative 3. So I'm really doing negative 1/2 times 4, negative 3, negative 2, 1. When I do that math, I actually do the multiplication. This is a scalar right here. This is a scalar. So 4 times negative 1/2 is negative 2. Negative 2 times negative 1/2 is positive 1. Negative 3 times negative 1/2 is 1.5. And this is going to be negative 0.5 or negative 1/2. You can write that with decimals or fractions, I don't care. This right here is the inverse of matrix A. Here is matrix A. Here is its inverse. If I were to do matrix A times A inverse, I would get out a bunch of 1s and 0s. And if I were to do A inverse times A, I would get out a bunch of 1s and 0s. I would get out the identity matrix. If you're going to try that on your own to see that, that's actually worth doing, but we'll do it in class. Find the inverses of these. Let's do it. Take a second, pause, find the inverse of these. I could have done that too. I could have paused. Here I go. 1 over B times 1, 8, 6, 2. These are negatives. Well, the determinant of B is going to be 8 minus 12, which is negative 4. That becomes negative 1/4. 6 over 4, which is 3 over 2. Negative or positive 1/2, and negative 2. This right here is my B inverse. To find the inverse of matrix C, I'll briefly show you how to do this on your calculator, but this is explained in detail in my next video. Turn this on, clear everything. Second matrix, second x to the negative 1 pulls up your matrix menu. So here's my matrix menu. That was second x to the negative 1. I'm going to scroll over to edit. I'm going to edit matrix A. So I hit enter on matrix A after I scrolled over to edit. I want to, right now it's a 1 by 1 matrix. I want it to be a 3 by 3. I'm going to type in these numbers. 5, enter. 2, enter. 1, enter. Enter is the button of choice to input things with your matrices. Don't press over if you can help it. Press enter. I want to get out of here, so I do second mode to quit. I'm going to quit out of that screen. Go back to second x to negative 1, which pulls up my matrix menu again. Oop, I didn't have to do that, I'm sorry. Oh, yes I do. I'm going to hit enter on names. I'm not going to go to edit. I'm just going to grab matrix A. This is now matrix A. You can show it to me there if you want. What I can do is I can grab matrix A and just press this button right here, and this is going to find the inverse of matrix A. That's what that x to the negative 1 does, finds the inverse. It's that ugly, messy decimal that I can scroll to the right and see a bunch of it. One thing that I can still do here, which is very nice, is press the math button. The first option is arrow frac. Hit enter a couple times. It'll take this answer, put it in fraction form. A little bit prettier this way. We don't find matrices of anything bigger than a 2 by 2 by hand. So 3 by 3, 4 by 4, anything bigger, the inverse would be found on your calculator. The important thing to remember, A inverse times A is identity, A times A inverse is identity. Thank you.